Hi, I'm Ben Pearson, the Roser Tracker. 50 years ago, the Apollo program was preparing to launch humans to the moon for the very first time to land on its surface. July 16th, 1969, Apollo 11 took off with 3 astronauts, with 2 of them destined for the moon. They arrived there on July 20th. It's been a long time since we've been back. It's been about 47 years roughly since the last one of these missions, Apollo 17, landed on the moon. We live in a time where, once again, NASA is working on actually doing that. They have a plan, it's kind of rough, but somewhere between the next 5 and 9 years, hopefully, we'll have humans back on the moon. Of course, this might totally change if someone like Elon Musk comes up with the Starship that SpaceX has been working on and is able to do it sooner, but we have a plan and it is probably going to happen by 2028. So that'll be really, really exciting. Still, that'll be 60 years since the Apollo astronauts went there. But what are we going to do something beyond what the Apollo astronauts did? Well, there's a plan to send humans to Mars using the SLS rocket. The SLS is, of course, NASA's approach to getting humans to deep space of any kind. It's this big giant rocket. It is roughly similar to the Apollo Saturn V rocket that took humans to the moon in terms of its payload capacity. Not identical, but close enough for most purposes. The only other rocket that's on the books that we know about that's being developed is SpaceX's Starship, which has a very similar payload capacity to SLS, although it can be refueled and do a lot of other really neat things. But let's just set that aside for the moment. How would you actually get SLS to Mars if you were going to do that? Well, you can get one thing there relatively easily, but it can't really toss that much payload directly to Mars. It's going to take a lot of launches of this spacecraft to be able to do anything really, really significant. Okay, so what would it take? Well, let's start from the beginning. First of all, you got to get the astronauts into space. You're going to launch them with an Orion capsule because that's exactly what the plan is going forward. The Orion capsule is going to not really leave Earth's orbit, but it's going to be on a highly elliptical orbit because that's the maximum force that SLS can actually do. Okay, but what are you going to do with that? Well, the Orion capsule is relatively small. You can think of it kind of like a van. It's not somewhere where you're going to want to hang out for a long period of time. And the mission to Mars, at a minimum, is going to be at least a year and a half. 2.5 years is a much more optimal version, but it's going to take a long time. So you might be able to have a few people hang out in a minivan for even a couple of weeks without too much complaint. But if you're talking a year and a half, no, just not going to happen. Okay, so what are you going to do? Well, you have to send a habitat. So you launch a habitat into orbit around the Earth. For a habitat to be big enough to really make a difference, you're not going to be able to get it beyond low Earth orbit with an SLS launch. So what do? Well, you launch a second one. You have the upper stage docked to this habitat module, and you launch it into the same orbit that Orion will be eventually sent to. The habitat, of course, will be sent first, and then Orion will dock to that habitat, and from there you can make it on your way to Mars. Okay, so what about landing on Mars? Well, you're going to have a dedicated lander for that. You're probably going to base it off of the lunar lander that is going to be flown somewhere between 2024 and 2028, hopefully. It will be able to make it maybe to low Earth orbit with a single launch, but to get it out to Mars, you're going to need a second launch. Now, you're going to send this out way in advance, and it's going to have a heat shield so you can slowly use the atmosphere of Mars to lower this down into orbit. For instance, the Mars Reconnaissance Orbiter that I'm very familiar with, over the course of about 6 months was able to lower its orbit down until it was in a low Martian orbit. And that's what you're going to want, and you probably want to do something similar, especially considering you're going to have a lot of time and a spacecraft that can already do this. Okay, so you have the lander, you have the spacecraft. What else are you going to need? Well, there's a few other little bits and pieces. See, the spacecraft, when it first enters orbit around Mars, is going to be in a highly elliptical orbit. What you do when you're entering orbit around anything is you want to burn as close to that object as you can, because you'll get the maximum birth effect, as anyone who plays Kerbal Space Program no doubt knows, and that will allow you to really take full advantage of this. Okay, what else do you need? Well, you need to be able to leave Earth. You could launch something on, say, a Falcon Heavy, perhaps, to make it to Mars, and that could dock with the habitat, and you'd be there. That's probably a good choice. The stage to get the humans from high Mars orbit to low Mars orbit could also be launched in advance and stay in that orbit around Mars. You're also going to need perhaps a stage to go from low Mars orbit back to the high Mars orbit. All three of those could potentially be launched by commercial vehicles. They're not going to really take a ton of mass, so Falcon Heavy is certainly capable of doing it. Delta Heavy might be as well. And that would allow you to do it. So you've got 5 SLS launches. You've got 2 for the habitat, 1 for the Orion, 2 for the lander and ascending vehicle. What about the time that they're on Mars? The lander, to go from Mars orbit to the ground, is going to be small. It's going to be maybe closer to a car in size. You're not going to want to live in that for very long. It'll be smaller than the Orion capsule. So what are you going to do? Well, as it stands, you either have to land a habitat on Mars, and that's going to take another couple of launches to be able to pull that off. And then you have to figure out how to get them properly positioned and so on and so forth. Sounds like a lot of work. Or you have the astronauts only stay for a relatively short period of time on the surface of Mars, maybe a couple of weeks. Then they have to come back and dock with their habitat. So that gets to be rather complicated. Because are you just going to go all the way to Mars, land on the surface, stay there for 2 weeks, and then you have to wait for 1.5 years to get back home? Probably not really what you're going to want to do. So what you could theoretically do is to send another stage. You could do this in a single launch that will not just take them back to Earth, but take them beyond Earth, which would take them to fly by the planet Venus. That would allow them to get home faster, and this mission could be done in 1.5 years. Sounds nice. It's a 1.5 year mission to have exactly 2 weeks on the surface of Mars, and it would take 6 SLS launches, take 3 commercial launches to carry things, and there may be some other ones that are not in there. The astronauts are going to launch to their habitat. The habitat will fire a rocket that will send it to Mars. It will enter a high Mars orbit. The Orion capsule will undock with the habitat, dock with a stage that will bring it down to the lower orbit. It will then let go of that stage, dock with the lander vehicle. The lander vehicle will then undock from Orion, land on the surface of Mars. It will launch the ascender stage after it's been there for a couple of weeks, dock back with Orion. Orion will use the stage it's placed there to help it to get back to the higher Mars orbit with the habitat. Then it will proceed to Venus, and it's just a lot of work, really, really complicated. So I just wanted to add a couple of little pieces though. This program could work without developing in situ resource utilization and only using launch vehicles plus the SLS rocket that we have or we're going to be using to get to Mars, although you would need a heat shield for a Martian vehicle, but it's relatively similar. Still, there's a lot that would have to be developed to make all of this work, and quite frankly, it's very difficult. But this program was shown by Hoppy Price, who's the chief engineer of Mars development over at JPL, as something that could theoretically be done. And it uses a lot of elements that are very, very similar to SpaceX's plans. It relies on some kind of fuel type transfer a number of times, although SpaceX will transfer fuel directly between vehicles. This involves some stages that are launched that will dock and provide a transfer stage. It involves a similar number of launches. Actually, the SpaceX plan relies on far, far more launches, although the SpaceX plan, you really only have two types of vehicles. You have the ones with three. You have ones with humans, ones with cargo, and ones with fuel, and that's it. Nothing else more complicated than that is needed. The boosters are all the stage, so 4 pieces of hardware that are all currently in some form of development. This could theoretically be done, but in situ resource utilization allows this to be done so much more efficiently. This is where we use the atmosphere of Mars, and possibly water or hydrogen that we bring from Earth, to generate the fuel to get home. And you would probably be able to do something to Mars with maybe 2 of these launches. 6 SLS launches sounds like an enormous amount. It would actually take about 3 years to have all of these launches provided, and because of the cycles and whatnot, it would not be something you would be doing very often. But the SLS program theoretically should be able to support 2 launches per year, and this would give them something to do. How is all this going to work? I don't know. And this is stressing, this is not a real plan that NASA's trying for. This is one hypothetical architecture that they could do. But it seems like an enormous amount of work, and whatever you do with SLS, it's going to have to do something like this. I mean, they're going to use 2 SLS launches just to get humans to the moon. If you're going to go into deep space, you're going to be using a lot more than that. Hopefully we can figure out something that will be better and allow us to do some really great exploration. SLS might be able to get us there, but there's a lot of other interesting things that are on the horizon. Thank you guys much for joining me. Let me know whatever questions or comments you guys have. Let me know if you have a better architecture that NASA has without using vehicles that haven't been developed yet, like Starship. Until next time, keep on tracking. Take care. Hi, Ben Pearson, the Rosa Tracker, and today I want to first of all congratulate the Apollo program. Hi, Ben Pearson, the Rosa Tracker. This is an auspicious memory in the history of this